You know all these incredible AI tools like ChatGPT? Ever wonder what the one big idea behind all of them is? Well, it's not some super complicated mix of 100 different things. Nope, it all comes down to a single brilliant concept from a 2017 research paper that basically changed everything, and that's what we're going to break down right now.
So what is this secret sauce? What's the thing that took AI from being, well, kind of slow and clumsy to the smart, creative tools we're all using every single day?
It all goes back to this one revolutionary paper that came out in 2017. A team from Google published it, and honestly, this one document is what kicked off the entire generative AI explosion.
The paper has this almost cheeky title, "Attention is all you need." And as you're about to see, they were not kidding. This one paper literally laid out the blueprint for pretty much all the AI that we interact with today.
Okay, so to really get why this was such a huge deal, we first have to talk about the big problem AI used to have. Basically, it was terrible at reading. See, before 2017, AI models had to read sentences in a really rigid way, one word at a time, from start to finish. This approach, which was the heart of things called recurrent neural networks, or RNNs, created a huge bottleneck.
Just picture this. Try reading a book by looking through a tiny little peephole, only seeing one word at a time. By the time you get to the end of a long sentence, you've probably forgotten how it even started, right? Well, that's exactly what old AI was doing. The new idea, the transformer, was a total game changer. It was like finally being able to see the entire page at once. It could look at all the words simultaneously, which made it way faster, and, this is the crucial part, so much better at getting the full context.
And that was the core problem, you know? In language, context is king. How is an AI supposed to understand a joke or figure out who he or she is in a story if it forgets the beginning of the sentence by the time it gets to the end? It just couldn't work.
And that brings us to the big breakthrough. The brilliant solution they came up with, a little something they called attention.
They called this new superpower self-attention, and what it does is pretty amazing. As the model looks at a single word, it can also look at every other word in the sentence at the exact same time. It lets the AI weigh the importance of all the words to figure out the real meaning. It could finally connect the dots, even if they were at opposite ends of a paragraph.
Let me give you a classic example that used to completely stump older AI models. Consider this sentence. The animal didn't cross the street because it was too tired. So the question is, what does it refer to? The animal or the street?
Now, for you and me, that's a no-brainer. Obviously, it's the animal. But for an old AI, that was a really tough puzzle. With self-attention, though, the model can instantly see a strong connection between the word it and the animal, and a super weak connection to the street. And just like that, problem solved. The context is locked in. But here's the thing. This wasn't just some clever new feature. The researchers built an entire brand new system around this one idea.
They basically took the old rulebook for processing language and threw it out the window. No more one word at a time stuff. This new architecture was built from the ground up, completely based on attention, and they gave it a name that would become famous: the transformer.
So how does this transformer thing actually work? Well, you can think of it in two main parts. First, there's the encoder. Its job is to read the input sentence, the whole thing, all at once, and really understand its meaning. Then you have the decoder. It takes that deep understanding from the encoder and uses it to generate the output, like a translation or an answer to a question. But the real engine powering both of them is something called multi-head attention. This is the coolest part. It's like having a whole team of experts reading the sentence at the same time. One expert is looking at grammar, another is figuring out who did what to whom, and a third is picking up on the tone. By working together, they build a way deeper understanding than any single reader ever could.
All right, that all sounds great on paper, but, the real question is, did it actually work? And the answer is yes. Oh boy, did it work. The results were pretty stunning.
So the team tested the transformer on a classic task, translating English to German. And it didn't just edge out the competition, it blew right past the best models that existed at the time. I'm talking even these super complex ensemble models, which were basically multiple AIs all mashed together to get the best result. The transformer beat them all.
It hit a quality score of 28.4.
Now, the metric they use is called a BLEU score. You don't need to know the math behind it, but what you do need to know is that back then, a jump of over 2 full points was, well, it was a massive leap. It was the kind of progress people thought would take years, not happen in a single paper.
But wait, here's the real kicker. It wasn't just better, it was also way, way more efficient. Because it could process all the words in parallel instead of one by one, it trained so much faster. It achieved these record-breaking results in a fraction of the time, using less computing power. This combination, better results and cheaper to train, that was the signal to everyone that a whole new chapter in AI was starting.
And this wasn't just some dusty academic paper that nobody read. No, that 2017 paper was the starting pistol for the AI race we're all living through right now.
I mean, you can draw a perfectly straight line from this paper to the phone in your pocket. The very next year, in 2018, the first ever GPT was built on this exact architecture. Then in 2020, GPT-3 came along and showed the world what happens when you make these transformer models really, really big. And then, boom, ChatGPT and this whole explosion of AI tools, every single one of them, deep down has that transformer architecture at its heart.
So let's just quickly recap the whole story. The big problem was that old AI models read one word at a time, so they couldn't grasp the big picture. The solution was the transformer, with its superpower of self-attention, which let it see the whole sentence at once and understand the full context. And the impact? Well, this huge leap in quality and efficiency became the blueprint for every modern large language model. It really turns out, attention was all you needed.